welcome back to my YouTube channel. So we did up till question number 1 in last lecture. Let's start with question number 2. So in question number 1 we were already given the factors. So we'll form factors in these questions and then find the interval. Let's start. So x square minus 25. We can convert it to x square minus a 5 square greater than equal to 0. So from here what we get is x plus a 5 times x minus a 5 is greater than equal to 0, and this gives us two zeros of this quadratic equation. So if we get x is equal to 5 or x is equal to minus 5, these two zeros break the real line into three parts. One is negative 5, one is 5. So we are getting these three intervals. We need to check for that interval for which the value of this quadratic equation is greater than or equal to 0. So for greater than 0, let's take first of all this first interval. So when x is less than negative 5, if we substitute that, let's take x is equal to negative 6. So if we substitute this value, we get 36 minus 25, and yes, it is greater than 0. If we substitute some value from this second interval, let's take x is equal to 0. So if I substitute it, I get negative 25. This is less than 0. So we'll not take this interval. And if I take, let's take 6 from here. So x is equal to 6. Yes, so 36 minus 25 greater than 0. So the intervals that we are taking are when x is less than negative 5 and when x is greater than 5. And since the sign is of equality also, so greater than equal to, so we'll choose when x is less than equal to negative 5 or when x is greater than equal to 5. All right, I hope it is clear. Let's move towards next question. So we have a quadratic equation over here. We need to form factors first of all. So product is 10, sum is 7, x square plus 5x plus 2x plus 10 is less than equal to 0. So from here we get x plus of 5 and x plus of 5. We can take x plus of 5 common. So x plus 5 and x plus of 2 is less than equal to 0. So from here, two zeros of this quadratic equation are when x is equal to negative 5 and when x is equal to negative 2. So we break the real line into three parts: negative 5, negative 2. So these are the three intervals. We need that interval whose x's give us a negative value for this quadratic equation. So let's choose. So when we take x is equal to negative 6, so if I substitute it over here, what I get is negative 6 plus 5 and negative 6 plus of 2. Both of these functions give us a negative value. So negative 1 and negative 4. The product is positive 4, which is greater than 0. So no, we'll not choose this interval. If we take a value from this interval, negative 5 and negative 2, so let us take one value, x is equal to negative 3. If I substitute it, what I get is negative 3 plus of 5 and negative 3 plus of 2. So yes, we get a negative value over here. So our result is negative of 2, which is less than 0. Let's take 3 over here. So 3 from this interval, if we substitute it, we get 3 plus of 5 and 3 plus of 2, a positive value. So this is greater than 0. So the values that satisfy this inequality are from interval negative 5 and negative 2. So our answer will be when negative 5 is less than, and we are also taking sign of equality for that. So negative 5 is less than equal to x is less than equal to negative 2. So this range is our answer. Factorizing it, product is -7, sum is 6. So x square plus 7x minus 7 is greater than 0. So forming factors, taking x common, x plus of 7 minus 1 common, x plus of 7 is greater than 0. X plus 7 and x minus 1 is greater than 0. X is equal to -7, x is equal to 1. These are the two zeros. So real line divides into three parts, -7 and 1. So what we want is the value of quadratic equation, value of y should be greater than 0. So we check the intervals. If I take -8 and substitute it over here, so -8 plus of 7 and -8 minus of 1, we get -1 and -9. So our value is actually greater than 0, right? So we get 9, which is greater than 0. If I take a value from here, x is equal to 0, if I substitute that, I get 7 times -1, which is -7, less than 0. If I take x is equal to 2, and if I substitute that, I get 9 and times 1. So 9 is greater than 0. So the intervals that I'm taking is when x is less than 7 and when x is greater than 1. So these are the two intervals for x. Let's move forward. Let's start. Let's sum the factors over here. So product over here is 14 times -6. So 14 times -6 is -84. And sum over here is 17, right? So if we try and simplify it, so if sum is 17 and product is -84, what we can say is it is actually 21 times 4, right? So we'll take positive 21 and -4. 14x square plus 21x minus 4x minus 6 is less than equal to 0. So we factorize it. So we can take 7 common over here and x as well. So it is 2x plus of 3 and -2 common, 2x plus of 3 is less than equal to 0. So 2x plus 3 and 7x minus 2 is less than equal to 0. So calculating zeros are x is equal to -3/2 or x is equal to 2/7, right? So the real line breaks into three parts, -3/2 and 2/7. So these are the three intervals. What we want is the value of this quadratic equation, value of y should be less than or equal to 0. So if I substitute values from these intervals, what I get is, so if I substitute one value from here, it's -3/2, -1.5. So I can take -2. So if I substitute -2, x is equal to -2, what I get is 2 times -2 plus of 3, 7 times -2 minus of 2. So this gives us -4 plus 3 and -14 minus 2, right? And if I simplify it, I get -1 times -16, that is equal to 16, right? And this value is greater than 0. So we'll not take this interval. Second interval is when we take x is equal to 0. So if I substitute that, I get 3 times -2, that is -6, less than 0, correct? We'll choose this. Third interval, when we take x is equal to 2. So if I substitute it, I get 4 plus 7, 4 plus 3, that is 7, and 14 minus 2 is 12, and this is actually greater than 0. So we'll also not take this. So only interval that we are taking is when negative 3 by 2 is less than equal to x is less than equal to 2 by 7. Alright, so this is the interval that we'll choose for this quadratic inequality. I hope it is clear. Let's move forward. We'll try and factorize it again. So forming factors of this quadratic equation, product over here is 6 times 20. So 6 times 20 is 120 and sum is negative of 23, right? So the values that we'll get is 15 and 8. So if I take negative 15 and negative 8, I'll get plus 20 as product. So splitting this middle term, 6x square, negative 15x, negative 8x, and plus of 20 is less than 0. I can take 3x common, I'll get 2x minus of 5, and from here I can take negative 4 common, I'll get 2x minus of 5, which is less than 0. 2x minus 5 and 3x minus 4 is less than 0. So from here, if I check zeros, those are x is equal to 5 by 2 and x is equal to 4 by 3. So 4 by 3 and 5 by 2, right? So these are the two zeros and we get these three sets of set of intervals. So if I take value from this first interval, I can take x is equal to 0, and if I substitute that, I get a value that is negative 5 times negative 4, which is actually 20 and greater than 0. So we'll not take this interval. If we take value from this interval, that is 2. So x is equal to 2. If we substitute that, we get 4 minus 5 and 6 minus 4. We get negative 2, which is less than 0. So yes, we will take this interval, and if I take a value from here, x is equal to 3. So if I substitute it, I get 6 minus of 5 and 9 minus of 4. So we get 1 and 5, which is 5, and this is greater than 0. So we'll also not take this interval. The only interval that we are taking is 4 by 3x is less than 5 by 2. So this is our answer. All right. So we need to simplify it first. We have 2 negative 2x square, negative 7x, and plus of 4 is less than 0. We need to take negative common in the left hand side. So it is negative 2x square plus 7x minus of 4 is less than 0. If we multiply negative both sides, this inequality will change. 2x square plus 7x minus 4 is greater than 0. Now we can form factors. So we factorize it, the product is negative 8. So 2x square plus 8x minus x minus 4 is greater than 0. We take 2x common, x plus a 4, and minus 1 common, x plus a 4 is greater than 0, right? So from here we can take x plus 4 common, and 2x minus 1 is greater than 0. So zeros are x is equal to negative 4 and x is equal to 1 by 2. These are the two zeros, right? And the real line breaks into three interval, negative 4 and 1 by 2. So if we check first interval, so what we need is that the value should be greater than 0. So if we check first interval, we take x is equal to negative 5. If we substitute it, we get negative 1 and negative 11. So that is 11, which is greater than 0. So yes, we'll accept this interval. If we take second interval, x is equal to 0, so we get 4 and negative 1, which is less than 0. So no, we'll not take this interval. Let's check third interval. When we take x is equal to 1, it is 5 and 1, which is 5, which is greater than 0. Yes, we'll also accept this interval. The intervals that we are getting is when x is less than negative 4 and when x is greater than 1 by 2. So these are the two intervals that we'll accept. And thanks for joining. That's all for today. We'll do the rest of the question in next class. Till then, take care.